Every single drop of water you've ever consumed has a story that spans billions of years. The water in your coffee this morning, the rain that fell yesterday, even the water in your own body. It all arrived on Earth through one of the most debated mysteries in planetary science. How did our planet become the only known water world in the solar system? Picture Earth 4.6 billion years ago. It's a hellish, molten ball of rock, constantly bombarded by asteroids and comets. Temperatures soar above 1,200 degrees Celsius. Any water that might have existed would have instantly vaporized into space. Yet somehow, within just a few 100 million years, this inferno transformed into a blue marble covered by vast oceans. The question that has puzzled scientists for decades is simple. Where did all that water come from? The answer isn't straightforward, and that's what makes this story so captivating. Scientists have proposed several competing theories, each supported by compelling evidence, yet none definitively proven. It's like a cosmic detective story where the crime scene is 4 billion years old, and the evidence is scattered across the solar system. Let's start with the most dramatic theory, the Late Heavy Bombardment. Around 4.1 to 3.8 billion years ago, something extraordinary happened. The inner solar system became a shooting gallery. Asteroids and comets, some as large as mountains, rained down on Earth with devastating frequency. This period, known as the Late Heavy Bombardment, delivered more than just destruction. Many of these celestial visitors carried something precious: water ice. Imagine comets as cosmic snowballs, dirty mixtures of ice and rock hurtling through space at incredible speeds. When they slammed into Earth, they didn't just create massive craters. They deposited their icy cargo, adding to our planet's water inventory. Scientists estimate that during this bombardment, Earth received the equivalent of several oceans' worth of water from these extraterrestrial deliveries. But here's where the story gets complicated. Chemical analysis of Earth's water reveals a specific signature: the ratio of regular hydrogen to its heavier cousin, deuterium. This ratio acts like a fingerprint, unique to different sources in the solar system. When scientists compared Earth's water signature to that of comets, they found a problem. Most comets have deuterium ratios that are significantly different from Earth's oceans. This discovery threw a wrench into the comet delivery theory. Enter the asteroids. These rocky bodies, primarily located in the asteroid belt between Mars and Jupiter, tell a different story. Many asteroids contain water locked within their mineral structures, and their deuterium signatures match Earth's water much more closely. This led scientists to propose that asteroids, not comets, were the primary water delivery service for early Earth. The asteroid theory gained momentum when researchers discovered that certain types of meteorites, called carbonaceous chondrites, contain up to 20% water by weight. These space rocks are essentially time capsules from the early solar system, and their water signatures are remarkably similar to Earth's oceans. It's as if we found the cosmic receipt for our planet's water delivery. But wait, there's another twist in this tale. Some scientists argue that Earth didn't need cosmic deliveries at all. They propose that our planet was born wet, with water already present during its formation. This theory suggests that water was incorporated into Earth from the very beginning, trapped within the planetesimals, the building blocks that clumped together to form our world. During Earth's violent early formation, this trapped water would have been released through volcanic outgassing. Picture massive volcanic eruptions releasing enormous clouds of steam into the atmosphere. As the planet cooled, this steam condensed and fell as torrential rains that lasted for millions of years. These primordial storms gradually filled the ocean basins, creating the water world we know today. The outgassing theory is supported by studies of Earth's deep interior. Scientists have discovered that our planet's mantle contains vast amounts of water, potentially more than all the surface oceans combined. This hidden reservoir suggests that water has been part of Earth's story from the very beginning, not just a later addition from space. Recent discoveries have added even more complexity to this puzzle. The Rosetta mission, which studied Comet 67P in detail, found that some comets do have deuterium ratios similar to Earth's water. This finding revived interest in cometary water delivery, suggesting that perhaps different types of comets contributed water at different times in Earth's history. Scientists have also identified a potential game-changer: Jupiter's migration. Computer models suggest that early in the solar system's history, Jupiter may have wandered inward toward the Sun before migrating back out to its current position. This cosmic shuffle would have dramatically altered the orbits of asteroids and comets, potentially sending water-rich objects from the outer solar system into Earth's neighborhood. The truth is likely more nuanced than any single theory suggests. Earth's water probably came from multiple sources through a combination of processes. Some water may have been present from the planet's formation, while cosmic bombardment added more over hundreds of millions of years. Different types of comets and asteroids likely contributed varying amounts at different times. This multi-source scenario is supported by the diversity of water signatures found in different parts of our solar system. The moons of Jupiter and Saturn, many of which harbor subsurface oceans, show that water delivery and retention occurred throughout the solar system, not just on Earth. The implications of understanding Earth's water origin extend far beyond satisfying scientific curiosity. As we search for life elsewhere in the universe, knowing how planets acquire and retain water becomes crucial. The same processes that gave Earth its oceans may be operating around other stars, creating distant water worlds that could harbor life. Modern technology continues to refine our understanding of this ancient mystery. Sophisticated mass spectrometers can detect minute differences in isotope ratios, while computer simulations model the complex dynamics of the early solar system. Space missions to asteroids and comets provide direct samples of these potential water sources, allowing scientists to test their theories with unprecedented precision. The story of Earth's water is ultimately a story of cosmic recycling. The hydrogen in every water molecule was forged in the Big Bang itself, while the oxygen was created in the nuclear furnaces of dying stars. These elements traveled through space for billions of years before finding their way to Earth, where they combined to create the substance that makes life possible. As you drink your next glass of water, remember that you're consuming a cosmic cocktail with ingredients older than the solar system itself. Whether delivered by comets, asteroids, or outgassed from Earth's interior, every drop connects us to the vast universe beyond our blue planet. The mystery of how Earth became a water world reminds us that our planet's story is far from over. It's still being written in the depths of space, one cosmic collision at a time.